Hello again, Year 11, welcome back. This is the fourth version of the 9-box division exercise. Same as always, what I'd like you to do is to pause the video now and have a go at all 9 questions. Give each of them a try to maximise your marks on all of them, and then after that, press play and I will start to talk through each of the questions individually so you can see exactly how well you've done and which topics you still need to work on. So question number 1 says, what is the probability I score greater than 4 on a standard dice? Now the key here is it's the word greater than. So scoring greater than 4 means you can either score 5 or 6, in which case that gives you a probability of 2 out of 6, which could have been simplified to 1/3 if necessary. Okay, so greater than 4, don't forget, means it doesn't include 4, so we're only counting 5 and 6. Okay, so the question number 2 is all about estimating. Estimating is one of those frustrating questions that quite often, when we try to answer them, we actually do it much more accurately than the examiner wants and we lose marks. So we need to underline the first number for each of them that isn't a 0. So for example, I underline the 2 for that one, the 4 for that one, and also the 4 for that one there. So I've underlined the first number that isn't a 0. I then round to that number. So for example, 27, the 20 is in the tens column, so I round to the nearest 10. 27 to the nearest 10 is 30. 4.8, the 4 is in the units column, so I round to the nearest unit, which rounds to give me 5. And the 0.48, don't forget, I didn't underline the 0, I underlined the first number that wasn't a 0, so that was the 4. That's in the tenths column, so I round it to the nearest tenth, which gives me an answer of 0.5. All I then have to do is actually work it out. So 30 times 5 is 150, and I'm dividing that by 0.5. Now you need to think very carefully. Think about division as how many goes into. So 150 divided by 0.5 is how many 0.5s, how many halves go into 150. Well, for every single one, we have 2 halves. So 2 of these go into every one of the 150s. So 150 multiplied by 2 gives me an answer of 300. Well done if you got that one correct, that was quite a tough one. Question number 3, simplifying a fraction. Well, the method I've taught you in class is to work out which number goes into both 35 and 63. Well done all of you who realised it was 7. And then we rewrite 35 as 7 multiplied by 5. And again we said 7 also went into 63. So 7 times what made 63? Obviously it's 7 times 9. And then what we can do is we can cancel both of our 7s, leaving an answer of 5/9. Okay, so question number 4 asks you to convert 2/5 into a percentage. Some of you might immediately know that 2/5 is equivalent to 0.4, and then you immediately that the answer was 40%. So the answer is 40%. However, some of you might not have known that 2/5 was 40%. So the other way of looking at it was actually, if we change the fraction 2/5, and we know that that's the same as 4 out of 10, isn't it? So if 2/5 is the same as 4 out of 10, which is the same as 40 out of 100, and obviously 40 out of 100, percent means out of 100, doesn't it? So 40 out of 100 must mean 40%. So there were 2 different ways of doing that. Hopefully people have started to realise that 1/5 is 20%, 2/5 is 40%, 3/5 is 60%, 4/5 would be 80%, and obviously 5/5 is a whole, which would give us 100%. So question 5, find the area of the circle, and I've given you the radius. Anybody who still hasn't been able to remember the difference between the circumference formulae and the area formulae, can you please go onto YouTube, type in circle song, and continue to listen to it until you're really, really confident with both of them. Obviously the circumference equals pi times diameter, pi d, whereas the area, so area equals pi times the radius squared. On this question, we are given the radius. We know it's 4, so in that case the area equals pi times 4 squared, or pi times 16. When you type that into your calculator, you get an answer of, to 2 decimal places, 50.27 don't forget your units. So it's 50.27 centimetres squared. Please don't forget your units. You always get a mark for those as well, don't you? Question 6, expanding the brackets. Don't forget, as soon as you see a question like this, you know immediately to draw your grids. So we start to draw our grids. We've got 3x, and we are multiplying that by 4x plus 3. 3x times 4x, well 3 4s are 12, and x times x is x squared. 3 times 3 is 9, and obviously we've got the x there as well. So I actually end up with 12x squared plus 9x. Now the key here, don't forget, as soon as you see something that looks like that, draw your grids, and then obviously multiply through it just like you would normally, and then simplify them and write them with the correct symbols at the end. So finding the nth term from a sequence, first you need to look at is what is happening to my sequence. So most of you have probably spotted that the sequence is going up in threes. Well, once we know it's going up in threes, we need to think about what else do we know that goes up in threes. Now the most obvious thing you're aware of is the 3 times table. So the 3 times table I'm going to call 3n, and I'm going to write the 3 times table underneath my sequence. So I've written the 3 times table directly underneath the sequence that I started with. If you look carefully now, you can see that the 3 times table and our starter sequence, how can I go from the 3 times table back to my starter sequence? Well, if I take 2 off each time, you can see 3 take away 2 is 1, 6 take away 2 is 4, 9 take away 2 is 7, 12 take away 2 is 10. So I'm clearly taking 2 away from the 3 times table, so in which case the nth term rule is 3n minus 2. Because it's the 3 times table, subtract 2 every single time. Number 8, writing all the factors of 40. Well, don't forget, 1 is always a factor, so we write them in factor pairs, don't we? So what numbers multiply to make 40 is what we're trying to work out. Well, 1 multiplied by 40 gives me an answer of 40. 2 multiplied by 20 gives me an answer of 40. I then try 3. Well, 3 doesn't go into 40, so 3 is not a factor. Does 4? Yes, it does. So 4 times what makes 40? 4 times 10. The next number, obviously, 5. Does 5 go into 40? Yes, it does. 5 times what makes 40? 8. Does 6 go into 40? No. Does 7? No. Does 8? Yes, it does, but I've already got it. So, therefore, all of my factors of 40 are 1, 2, 4, 5, 40, 20, 10 and 8. Really important that you write them out as factor pairs. So what number multiplied by another number goes into 40? I always start off at 1, then try 2, 3, 4 and so on, until I end up with another number that is already on my list. Finally, finding the area of a trapezium. Again, make sure you're happy with the name of the shape. Don't forget, the trapezium has got 1 pair of parallel sides, so always look out for those. Again, you have to learn the formula. There is a song on YouTube, feel free to go away and Google the area of a trapezium song. It might be quite helpful. But most of us are aware that we need to have the sum of the parallel sides. Well, the parallel sides are the 2 sides I've just made marks on there, look. So there's my 2 parallel sides. So half of the sum meaning add, the parallel sides. Let's do it one step at a time. The sum of the parallel sides is obviously 6 plus 10, which is 16. So half of the sum is half of 16, which is 8, times the distance between them. So it's half the sum of the parallel sides times the distance between them. Half the sum of the parallel sides was 8. The distance between them is 5. So 8 times 5 gives me an answer of 40 centimetres squared. Don't forget it was area, so we must include our units again. As always, well done for logging in and watching the video. It will make a difference in the long run. And again, look back in a couple of days where there'll be another one posted for you to do exactly the same thing. 15 minutes a day, so important. Let's keep working hard so we guarantee those grade C's, please.